Hi everyone, so this is like a bit of an add-in lesson. It's actually second year stuff, but it makes sense to do it because we've just talked about PMCC and the R number. Now in theory you don't need to work out the R number, but it's dead easy to do because you just put your numbers in list 1, list 2, and then you do 2 there instead of 1 there. Right, so this is supposed to be a 1 lesson, so we'll try and rush through it. Right, okay, that's not quite. Let's jump to page. So we know that R gives us a value for our correlation. If R is -1, it's perfect negative correlation. If R is +1, it's perfect positive. If it's 0, there's no correlation. And then we can have varying different degrees of positive or negative correlation. Right. So the population is everything. We've kind of mentioned that before with the X bar stuff. The sample is where we grab some data from it, hopefully randomly. R is our letter that we use for the PMCC. Then we've got another one, which is rho, which is this one here. And that is like the R value for the whole population. Now what hypothesis testing does, it checks your sample R value against the rho for the population. And it tests to see if your sample looks like the population or if it doesn't look like the population. Right, so this is quite a nice visual really. The whole population here has got no correlation whatsoever, but I might take a random sample, and if you look, this one here has got really, really strong, good, positive correlation. So I've got positive correlation here, but the population has got no correlation. So I'm kind of testing to see, in reality, if my sample is representative of the population. And this one's got like really good negative correlation. You kind of see the idea that we're getting at. So this is what this bit's saying here. Suppose the data entire population has got no overall correlation, but we take 2 samples and we've got strong positive and strong negative. So our R values are close to ± 1. We don't really know, we're not 100% certain if the sample we've got is representative of the population. So we use hypothesis testing. We have 3 hypothesis tests on the course. This one's the easiest one to do, and it's nice to set it up. Right then. So here we go. So idea behind hypothesis testing and significance comes up many times in stats. So it says if we were told a member of the class was psychic and we asked them to guess if a coin landed on heads or tails on each of the 20 throws, how would they have? How many would they have to get right to be statistically significant? So that's kind of testing that we do. Right, so PMCC looks at the linear relationship, which we kind of know because we've already, like the PMCC, the R number, correlation you've done at school has only ever been for linears because you just drew line of best fit. There's more out there. Right, so there's this thing called the null hypothesis and the alternative hypothesis. We use H0 for the null hypothesis, and that's what we think it is. So what we're saying is our assumption for these is that there's no correlation in the data. So we always set that up as no correlation. And then the alternative could go either of 3 ways. I can either say, do you know what, I think there is negative correlation, or do you know what, I think there is positive correlation, or do you know what, I'm not really much fussed, but I think it's different. And then with the difference, so the one-tail test are the negative or the positive, and the two-tail is a little bit vague. Now we have something called the critical region, and it's if our R value is far enough away that it lies in this critical region, because the critical regions are at the ends. And what you're seeing is my sample far enough away from the middle to say, oof, actually, I think this is a bit dodgy. So I'm kind of seeing if my sample is far enough away to say there's an issue. And that's kind of what the alternative hypothesis does. But we do other ones. We're testing the mean. So a population, the average is 20, and we have a sample and the average is 16. And it's with that 16, it's far enough away from the 20 for it to make a difference. That's kind of what we're doing. Right, so for us, it's not much working out really. We use a table of critical values, which I think is on your back page in the pack. I'm not entirely certain. Let's have a quick look. Is it on the back page of the pack? Yeah, there you go. So if your sample size was 10 and you were doing a one tail at a 5% significance level, then that would be the value I'd check it against. So that's a one tail at 5%, but if it was a two tail at 10%, it's the same value. If it was a two tail at 5%, it would be that one. We'll talk about more about that when we get to it. I'm kind of aware it's a lot of me chattering. There's actually a lot of theory to set up here. So here's the important bit. So if the sample doesn't lie in this critical region, we're okay. It's fine. It's not far enough away. But if it does, then we've got an issue. There might be something wrong with it. That's kind of what it says. Without an example, it's hard to show. Right then. So it says here, sample accounts taken to measure how effective it is. Consider the following data. So I've got an R value of minus 0.913. That's really, really strong negative correlation. And this is my sample, isn't it? 2, 4, 6, and is 7. So it says, so we want to see if there's significant evidence. If that value is far enough away for it to make a difference to what it should be. So my null hypothesis is that rho is 0, there is no correlation. Now, I want to see, it's not clear in this question, but this has done it as a one-tail test to say that there's definitely negative correlation. So that's what that's doing. But we're seeing if it's a negative correlation. So we set it up as no alternative. The significance level is 5%, so that's 0.05. And the tail is a one tail because it's just a less than. So what I'm doing is I'm looking at the bottom 5% of my population. That's what it means. Now R was what we got. That's a test statistic, and the critical value is what I'm going to get from my tables, which I'll show you in a second. Well, actually, we can see there for any 7 for a one-tail test, which was a top line. So one tail was a top line. At the 5% significance level, it gives me a critical value of 0.6694. But because it's at the bottom, I go negative there. So our critical value there, our critical region is minus 0.6693 and 694. Our test stat is minus 0.913. Our test stat is inside the critical region. So our R value is inside the critical region. So if that's the case, I reject H0. So there is sufficient evidence at the 5% significance level to suggest a negative correlation between the speed and the fuel consumption. So that's a full one. Got 15 seconds left. People remember their layout there as not all stats teachers talk crap. Right, gotta go. Bye-bye.